Hello everyone, so welcome back to my YouTube channel. This is Kasaligan Vlogs, and today we will be talking about area between two curves, that is calculus 2. So the area between two curves, this is an introduction, that the area between two curves is the area that falls in between the two intersecting curves. So this is what we call as the area between two curves. That is the intersecting curves y is equal to f of x and y is equal to g of x. So area is equal to the area of f of x, this is the upper minus the lower. So this is the upper equations and the lower equation or the function from a to, this is the limit from a to b. So this is the boundaries of this one from a to b, and this is with respect to x. So are there cases in practical situations or in practice in getting the area of two curves? So we need to compute it by using strips. So in practical, to find the area of the region bounded by y is equal to f(x) and g of x, we have to simply draw a typical rectangular element or variable rectangle whose edges are either parallel to the x-axis or the y-axis. For example, this one, we need to get the strips. Okay, strips of this one. Or we have to by looking at by horizontal or vertical strips. The rectangular element is drawn to parallel to y-axis, and this element is referred to as the vertical element or the vertical strip. So this is, we need to have a strips in order for us to get the area. So rectangular element. Again, in practice, to find the area of a region bounded by y is equal to f of x and g of x, we have to simply draw a typical rectangular element or variable rectangle whose edges are either parallel to the x-axis or to the y-axis. And there are two cases here. Case number one, area between two curves with respect to x. Okay, this is the vertical strips with respect to x. I mean to say from here up to here with respect to changes of x or the dx. To find the area between two curves, we need to divide the area into many small rectangular strips parallel to the y-axis from A to B. These rectangular strips will have the width of dx, this one, and the height of y is equal to fx minus g of x. So f of x shall refer to the upper curve and g of x shall refer to the lower curve. So defining this one, we have here area is equal to f of x minus g of x with respect to x from A to B. So this is case number one using the vertical strip. And case number two, area between two curves with respect to y. So horizontal strip, the area between two curves with respect to y-axis is the method of calculating the areas of the curves whose equation is given in terms of y. So this one, the function is, all the functions is in terms of y. So the same way here, this is dy, and f of y, and this one f of y and g of y. So these strips here is f of y minus g of y. Okay, dy. gy shall refer to the left curve, and xy is to the right curve. Okay, right minus the left. So the right minus the left. So gy is the left curve. Here one, and this is our this one, gy, and our fy is this one. So therefore, this how to compute area is equal to area is equal to from left chord right chord minus left chord. So this one is our left chord. So our right chord is f of y minus the left chord. So, okay, let's proceed with example number 1. This is the vertical strip. So find the area bounded by y is equal to 3x and y is equal to x squared. So the first thing that we're going to do here is we need to find the intersection between the two functions. So y is equal to 3x and y is equal to x squared. So we have here x squared is equal to 3x. So this is y and y. So x squared minus 3x is equal to 0. So factor x times x minus 3 is equal to 0. So x is equal to 0 and x is equal to 3. So now we have here the value for x. So we need to find the value for our y so that we could get the intersections. So the area that bounded by y is equal to 3x and y is equal to x squared. So when x is equal to 0, we are going to substitute here 3 times 0, y is equal to 0. When x is equal to 3, so y is equal to 3 times 3 by this equation. So y is equal to 9. So therefore, we have here, our equation is, our intersection is 0, 0, and also the next one is 3, 9. So we have the graph here. So 0, 0. This is a very important to need to graph. And 3, 9. So we have here 3, 9. Okay, so we have now 0, 0, and 3, 9. So the next step is we need to have a vertical stripping. So we have here, like here, we need to have a vertical strip. Okay, this one is dx. So since the area is with respect to x or dx, the functions is in the forms of x. So our change, or with respect to x, our change is from this point 0 to this one 3. So our limit or bounded from 0 to 3. Here 1, 2, 3, and 0 with respect, because this is a vertical stripping and it is parallel to the y-axis. So area, okay, so we have now the limit from 0 to 3. Okay, from 0 to 3, and since this is the equation is here is y is equal to 3x, and this blue one is equal to y is equal to x squared, our upper curve or upper function is 3x and minus the lower function, which is x squared, with respect to x. Okay, so next part here is we need to integrate now. So this is 3x squared over 2 minus x cubed over 3 from the bounded by 0 to 3. So our area here is 3 times 3 squared over 2 minus 3 cubed over 2, then minus 0, because if we're going to substitute it all by 0, the result is 0. So therefore area is equal to, this is 27 over 2 minus 9 over, rather 3. So 9 over 3. So 27 over 3. Okay, 27 over 3. So 27 over 2 minus 27 over 3 is equal to 9 over 2 squared units. So this is the area that bounds here. This is our area, which is 9 over 2 or 4.5 squared units from 0. So this is an example of vertical strippings or vertical strip. So we could also solve using the horizontal strip. Okay, so let's focus on horizontal stripping. So in horizontal stripping, so we are going to, the function is with respect to y. Okay, the function is with respect to y, so we will transform this. Y is equal to 3x, so therefore x is equal to 3 over y. And also y is equal to x squared. It would become y, okay, y is equal to x squared. It would become y is equal to, our x is equal to raised to, y is equal to raised to 1/2. Okay, so since this is our upper function, so this is the upper function, this is lower function, so we need to get the area by horizontal stripping. We need to get the horizontal stripping here. Okay, this one as our function is equal to x squared, and the function of this one, y is equal to 3x. Okay, same problem. So this is this one, and this is our dy, the change of this one. So what is from here 0, this is 0 0 and 3. Okay, this is the intersection 3 9. Since that is with respect to y, so from here 0 up to the bound here 0 to 9. So we have now the limit. Our area is equal to integral of 0 to 9, our bound here. Since upper function minus the lower function, so we have here upper, okay, okay, then we have here y raised to 1/2. With respect to y, rather, left or right. So this is now in a left or right, not an upper or lower, but this is from left to right. So therefore, from this one, from right minus the left. So our right here is y is equal to x squared. So therefore, y raised to 1/2 minus the left is 3 over y. Again, when talk about horizontal stripping, from left, right minus the left. So our right here is y is equal to x squared, and our left is y is equal to 3x. Unlike here in the first equation, where we're in from upper function minus the lower function. Here, from right minus the left. Okay, so with respect to y. So area is equal to, so we need to find here, first integrate first is 1. So we have here y raised to 1/2 plus 1 over 1/2 plus 1 minus, this is y over 3, rather this is y over 3, y over 3. Okay, this is y over 3, so therefore this is y squared over 6. Okay, y squared over 6, and the limit is 0 to 9. So area is equal to, this is y raised to 3 halves over 3 halves minus y squared over 6, and 0 to 9. Area is equal to 2, 2 raised to 3 halves over 3 minus y squared over 6. So we have to substitute here the value from 0 to 9. So our area is equal to 2 times 9 raised to 3 halves over 3 minus 9 squared over 6. then minus 0 since this is 0. So area is equal to, so we have to compute square root of 9, 3 cubed, okay, 3 cubed, that is, okay, square root of 9, 3, 10 cubed, that is 27 times 2 times 2 is 54 over 3 minus 9 squared, 81 over 6. So we have here 54 over 3 minus 81, 81 over 6. That is, area still is 9 over 2. Same process, square units. So this is an example of vertical strip and horizontal stripping. Okay. So next we have here example. Find the area bounded by y squared is equal to x and y squared is equal to 2 minus x. So this is okay. So we can transform this one as x in terms of x, y is equal to the square root of x and y is equal to the square root of 2 minus x. Okay, we could have this one in terms of x or in terms of y, or we could have this. Okay, okay, so in terms of y, we have to show this one. We could compute it by using the horizontal stripping based on this equation because we have graphed already y squared is equal to x and y squared is equal to minus x. So first we need to find the intersection. So the intersection is y squared is equal to x and y squared is equal to 2 minus x. The intersection is x is equal to 2 minus x. So this is 2x is equal to 2x is equal to 1. So when x is equal to 1, okay, this is 2x, x is equal to 1. Since this is parabola, the curves intersects at 1. If this is R1, here, for example, y, or x is equal to y is equal to the square root of x. So y is equal to positive and negative 1. So therefore, when x, okay, when x is equal to 1, okay, it could be 1 or 1. So here, okay, so this is the intersection when x is equal, so therefore 1 and 1 or 1 and negative 1. So this is the point of intersection. Okay, next is we need to use the horizontal stripping here. Much better, horizontal stripping. Okay, this is dy. Okay, all with respect to y. Okay, since that is with respect to y, so this is x is equal to y squared, and this is x is equal to y squared minus 2. So this is horizontal stripping, that is x is equal to y squared, and x is equal to y squared minus 2. So from left to right, so our area bounded from left to right here, since the change of y here is from 0 to 1. Since this is from 0 to 1, and the reflection here is 0 to negative 1, so the area is equal to negative 1 to 1. So from left, our equation here, this one is y squared is equal to 2 minus x, and this equation is y squared is equal to x. So from left to right, so therefore the first equation that we're going to have is y squared is equal to 2x. So from right to left, rather right to left, so y squared, okay, this is x, this is not, this is 2 minus y squared. So 2 minus y squared minus y squared with respect to dy. Since area is equal to negative 1 to 1, so we could have by the identity or the property of this one, definite integral, we could have multiplied to integral of from 0 to 1, because this is just a reflection here. So 0 to 1. So 2 minus y squared minus y squared dy. So this is the area is integral of 0 to 1 twice to 2 minus 2y squared with respect to y. So our area is a 2. Okay. So this is 2y minus 2y cubed over 3 from 0 to 1. Okay, so area is equal to 2. This is 2 times 1 minus 2 times 1 cube over 3. Then this will become minus 0. So area is equal to 2 times 2 minus 2 third. So 2 minus 2 third is 4 over 3 times 2, that is equal to 8 over 3 squared units. So this one, the area of this one bounded is 8 over 3 squared units. Okay, that's an example of horizontal strippings. Next, let's proceed with example number. Okay, let's go back here. So the first step that we're going to do in finding the area bounded by y is equal to x squared and y is equal to 2x plus 3 is we need to find the intersection. So x squared is equal to 2x plus 3. So therefore x squared minus 2x minus 3 is equal to 0. We have to factor x plus 1 and x minus 3 is equal to 0. So x is equal to negative 1 and x is equal to 3. So when x is equal to negative 1, so y is equal to negative 1 squared, y is equal to 1. When x is equal to 3, so y is equal to x is equal to 3, so 3 squared, y is equal to 9. So the ordered pair of the intersection is negative 1 and 1, and also we have here 3 and 9. So this is negative 1 and 1 and 3 and 9. So this is the intersection. So the next step that we're going to do is we need to have the vertical stripping here. Okay, since this is the vertical stripping, because this is y is in terms of x. Okay, all the functions is in terms of x. So this is the vertical stripping. So we have here, this is the equation y is equal to 2x plus 3. And this one is y is equal to x squared. So this is from upper to lower. So from upper to lower. So from this is negative 1 to 3. So the area is equal to negative 1 to 3. That is the bound or the limit when in terms, because this is in terms of x. So the change is dx. So first is upper. So we have here upper is 2x plus 3 minus the lower is x squared with respect to x. So we have to take first the integration of this one. So integral of this one is 2x squared over 2 plus 3x minus x cubed over 3. Then the bound here is negative 1 to 3. So area is equal to, we have to substitute simply 2 times 3 squared over 2 plus 3 times 3 minus 3 cubed over 3. Then minus, we have 2 times negative 1 squared over 2 plus 3 times negative 1 minus negative 1 negative 1 cubed over 3. So our area here is, this will become 9 plus 9 minus 27 over 3 minus 1 minus 3, and this will become plus 1 over 3. We have to simplify this one. So area is equal to 9 plus 9. So 9 plus 9 minus 27 over 3 is equal to 9. Then minus 1 minus 3 plus 1/3 is equal to 5 over 3. So area is equal to 9 minus 5 over 3 is equal to 22 over, is that correct? Okay, so this is 5 plus the 5 over 3. So this is plus 5 over 3. This is 32 over 3 squared units. So this is how to solve for example number 3. Okay, so try this at home. Find the area bounded by the given curves. X squared is equal to 1 minus 1 and x is equal to 1 minus 3 and y is equal to x squared and y is equal to 2x minus x squared. Thank you so much for listening, and solve this one and submit that one during our meeting. Let's try this.